Hello everyone. So the next experiment which we are going to do after the bandpass filter is a band reject filter. So in the previous experiment, that is bandpass, I've told you what is actually a band reject filter. So now we are going to design this. So this is the circuit which how we are going to design. The first procedure, we go and open the Cadence Capture CIS slide. So after this, we need to go for new project. So click on the new project on the window. Then you need to give some name. So I'll give it as band reject filter. Then choose the path where you need to save. Then give OK. OK. So you'll get the schematic window where you need to draw the circuit. Now, as we have seen in the circuit, we need 3 op-amps. So initially, we'll take 3 op-amps for the circuit. That is, if you see, this is actually a combination of a high pass filter, a low pass filter, then a summer. So we'll have first, this is resistor. So this is a low pass filter. This is capacitor. So this is high pass filter. So first, we'll do this configuration considering, so you have band reject filter schematic. Click on the page 1. Now you need to go for place part. As I've said, you place part will be here also, or you can take it from here, place part. Now we need to go for op-amp, in that it is LM741. So LM741 op-amp. So double click on this. You need to place one here, one here, and one more for the summer. Okay, then escape. So come back to the circuit. We need 1, 2, 3, 4, 5 resistors. So we'll go to show analog. We'll take a resistor. Double click on this. So a resistor has to be placed, one is to the third terminal of the op-amp, somewhere here. One more resistor, it has to be to the again third pin, and it has to be rotated. So we'll rotate it later. And one more output of this particular op-amp, and one more to the output of this, and one to the feedback of the summer. Okay. Now give escape, and we need to rotate this. So you can either do this option or do Control R. Then we need a capacitor. So double click on this. One capacitor which has to be rotated here. One more is here, and yeah, 2 capacitors. Okay, then escape. Now we need to do the connection. Before that, we'll take the inputs also. So by taking all the components, then we can do the circuit. So this is VAC. You type it, you'll get it as VAC. Double click on this. So both the inputs are same. I mean, for both the circuits, you can place it here. Give escape. Then we need VDC. Okay. So double click on the VDC. So we have initially +7, 3 op-amps. So one here, one here, one here, one here, here for this, and one more for this. Okay. So ground we can give it at the last, so you can close this. Now we have to draw the circuit properly. So this is the summer, so we'll complete the sum of R first. So this is actually +7, so you can rotate this. So plus has to be connected, so negative is here. Here I have to bring the negative to 4, so rotate it. Again once more you can rotate. So this is the negative part, and the one more resistor here. Now take a wire, connect it from 7 to here, here to here for the ground. Then from 4th terminal to here, and from here to ground. Similarly, from 6th pin, it has to be given to the resistor. Okay. Now we need to complete the circuit. From 3rd pin Go to the resistor. So I will finish up the circuit faster. So this is actually for ground. Resistor has to be actually for the ground. Third pin. And you have to delete it. Okay. This is how we join the circuit. I think all the points are connected. So a resistor, capacitor, capacitor into resistor. There's a feedback, supply, negative supply with a feedback, a supply. There's a resistor given to the summer. Number 3 should be connected to ground. Okay. Now we need to connect the ground for the circuit. So select the 0 COPS5M. So connect to the grounds wherever it is required. One to here and one more to this resistor end. To all the supplies of the op-amp. You have to be careful when you get the connection. Check it properly whether it is connecting. Here this has to be extended. Okay, the third pin of the summer. Okay. One more is required for the input. Now we'll connect this input, ground to the supply. Okay. Similarly to the input. So now one is input has to be given to both the settings here. Now we need to change the values of the input whatever we have taken. So the 1 kilo ohm as the resistor R1, capacitor value is 0.1 microfarad, so 0.1 microfarad. Similarly, this capacitor is again 0.01, so 0.1 microfarad. Resistor value here we have taken it as 2 kilo ohm, so 2 kilo ohm. Supply need to be changed. It is plus 12, and to the terminal 4 it is minus 12. That means we'll get 12, but the polarity is changed. Similarly here also it is plus 12, and here it is 12. There is one more ground required here. Okay, so this is done. Now this resistor, it has 10K, both the resistors R3 and R4. 10K. Okay, it is 10K. In the notations, it depends on, in the manual it is different, R2 and R3. It depends on how you place. So whichever the resistor you place first, and it takes the consecutive one. Next one is also 10K resistor. So we need to change the polarity. Supply plus 12. Similarly here this is 12. I think we are done with the circuit now. So all the parameters have been completed. Now we need to check the output across the side. We'll consider this voltage node and place it across. Pin number 6. Now if you save, you can save. After saving, the next step is you have to place. Go to Pspice, new simulation file. I'll give it as narrow band reject filter. You can create. So you'll get an edit simulation file. So now in this edit simulation file, the process remains same as previous, but you should be careful that till which frequency you have to reject the frequencies and which one you have to pass. So this is AC speed again, and here also start frequency. So I want to start the frequency as 50 hertz and end the frequency as 3 kilo, and point also I'll consider it as 10 for this. Now apply to all. Okay. Okay. Now after edit simulation file, we need to run the setup. Now before running, okay, this is not 1K. This has to be 8K. So give it as 8K. Now we'll save it. So we have done the edit part, simulation part, and we need to run the file. Check now whether there is any error. So there is no error because netlist generation is completed. After that, okay, before that, there was one problem here which I have corrected. This was not connected to 6th pin. Instead, it was connected to 1st pin. I just to make it proper, connected to 6th pin. This one is offset which we don't use. Now we have got the simulation file. Okay, see. So this is the band reject filter. The start frequency which we had taken or which we had considered was from 50 hertz. So we are getting from 50 hertz. It is rejected. So this will be the center frequency. Then it is passing till, stopping till 3 kilohertz. So from 50 to 3 kilohertz, it needs to stop the frequency. Rest all frequencies, it will be coming under the pass band. So this is actually your narrow band pass filter. If this is in terms of wide, then we call it as a wide band reject filter, not band pass filter. It's a wide narrow reject filter. So here usually the higher frequency what we take will be around 800. And what if we take a 3 dB? Similarly, the lower frequency will be coming around 200. So we'll get around the center frequency or bandwidth which we get here is very less, around 600 hertz we'll be getting. So this is how we do the narrow band reject filter. So the application of see the same waveform we have got which is given in the course lab manual. So again the result is that we will be using a Pspice tool and you'll be getting the output waveform of band reject filter after simulating. So the outcome is you will be having a first order band reject filter which is designed and analyzed. Application of both the narrow band pass filter and band reject filter is it is used mainly in wireless transmitters and receivers. It is used in electric guitar applications or amplifiers. So in telephone technology, these filters are used as a telephone line noise reducers and digital subscriber line internet services, mainly used in optical communication technologies. So this is how you simulate the band reject filter in terms of narrow. So